Hi everyone, it's Dr. Hollander. This week we're going to be discussing the NIET rubric. This is part one of a two-part presentation, mostly because this presentation could go on and on forever, and I did not want to spend more than 30 minutes lecturing at you all this week. So we're going to be discussing the NIET rubric, what it is, and how we use it. So this week, we're going to describe exactly what the rubric is. We're going to go through the first 9 parts of it. It's a 19-point rubric. I'm going to explain why we use it at Nicholls State University and how other parishes are using it as well. And then we are going to finally apply what we learned this week to some lessons that you've either created yourself or have taught if you're using scripted curriculum. So, NIET rubric adoption. At Nicholls State, we do something called the POP cycle, and all pre-service teachers undergo the POP cycle. In that, they meet with their university coordinator, and they have something called a pre-conference. That's when they discuss with their professor what they're planning on doing. And during that time, if you do a POP cycle with me, I start to ask you questions like logistics, and I start asking you questions to ensure that you're thinking about this rubric and how your lesson is going to meet it while still meeting the student learning objectives that you have to meet as well. Then I attend your lesson and I observe you if that's either virtually or in person. And then afterwards, we have a post-conference meeting where I share all the evidence I collected on why I scored you the way I did using the specific rubric that I will be presenting to you today. If I get to observe you teaching for this course, we will also use the NIET rubric, but would likely only do the observation and post-conference. We don't do pre-conferences for courses necessarily, but we do the entire POP cycle for our pre-service teachers and our master's level seeking teachers who have to be fully observed, not just for their course, but to graduate and to meet the state requirements in Louisiana. Additionally, the NIET rubric is being adopted by various parishes, and Louisiana is considering replacing Compass with this rubric. So even if you are not in the Lafourche parish, which is where it is currently being adopted, it's very likely that you will be seeing the NIET rubric in your future. So it's good for you to start familiarizing yourself with it now and maybe making some comparisons between that and Compass, which is what we use in Louisiana to assess our teachers, so that you can start to think about how what you do well on Compass is going to translate to how you will do well on the NIET rubric. Okay, so there are a lot of parts to the NIET rubric. A lot of it focuses on instruction, which makes sense, right? We are training to be teachers. So within instruction, we look at how you present standards and objectives, how you motivate your students, how you present instructional content, how you structure and pace your lessons, what activities and materials you use in your lessons, how you question your students, what type of academic feedback do you give your students? How do you group students? We also look at your teacher content knowledge. How well do you know the material you're teaching, as well as your teacher knowledge of students? So how well do you know your students that you're teaching? We also look at how you get your students to think and how you get your students to problem solve. Additionally, we do look at your instructional plans. So in planning, we look at the instructional plans. We also look at your student work. So during that observation, I would walk around, I would talk to your students, I would look over their shoulders and actually observe their student work, as well as what assessments you're using during that lesson. Additionally, we also consider environment. So we look at how you make your expectations of your students explicit, how you manage student behavior, what the environment of the classroom is and the environment that you are creating, and if you are creating respectful culture. And then finally, we also look at professionalism. So how is the teacher growing and developing professionally? We don't expect you to get a perfect score on this rubric. We expect to see growth over time. Also, how you reflect on your teaching, what type of involvement you have with your school community, and what responsibilities you have with your school. So I've posted the rubric on your Moodle shell, and I'm going to talk about it very briefly. So you should see the rubric on your screen. It is the NIET instructional rubric. It is 6 pages. It is 6 pages, yes, because there are 19 points on this rubric. And how you look at this rubric is first, on the left-hand side is each category that we are examining when we come to observe you. So as you can see, standards and objectives, motivating students, presenting instructional content. These were all things that I had stated in the previous slide. So these are all the different areas that we look at. And then you'll notice that there are 3 sections on this rubric. You have the section where a student could earn significantly above expectations or a score of 5. This is the highest score you can make in a section. And so you can see all the points that a teacher has to do to earn that 5. Now, this is specific to my candidates. Rarely are you going to make a 5 as a brand new teacher. You may make a 4, you may sometimes make a 5, but do not expect 5s across the board ever. It pretty much means you're a perfect teacher. And I can tell you that all the years that I have been teaching, all the years that your mentor teachers have been teaching, very rarely would they make 5s, because that means there's no room for improvement. And I think we can all agree that as teachers, we can always be improving. Now, to graduate at Nicholls State and to show that you are completely competent in teaching, you need to earn a 3. And a 3 is at expectation or proficient. So that means you're nailing it. You're doing a good job. You're doing exactly what you need to be doing right now. Maybe you could improve a little bit, but really like you're doing spot on a good job. And so these are the points that you have to make a 3. So you'll notice that there are these bullet points that explain what evidence I need to see or observe for you to earn a 3. Now you can also earn a 4 if, let's say, I collect evidence of all these things and then one more bullet point, but not all the ones that are in the section of 5. Now, anyone who is not meeting these standards would be getting a significantly below expectation, and that would be a score of a 0, 1, or 2. And these are going to be areas that we would want to improve upon. So after I observe you, if you earned a 0, 1, or 2 in an area, I would give you tips on how to master this area for the next time. So let's say you didn't do a very good job in motivating your students. If I were to give you a 0, 1, or 2, then I would also be giving you a lot of tips on what you can do for your next lesson that I come to observe to ensure that you can earn a 3 next time. So in the state of Louisiana, to graduate from Nicholls State, your observations need to be the majority at expectation or proficient. So if you are earning almost all 3s on this NIET rubric, then you are doing just fine and you are exactly where you need to be. For my master's level students, the same goes for you, although because many of you will have been teaching for 3+ years, you might be earning more 4s than 3s just because you have that experience and you've taught these lessons a few times before. But like I said, if anyone ever earns a 0, 1, or 2 in an area, that would be an area that we would focus on your improvement for the next time that I come and observe you. So please check out this rubric. It is on the Moodle shell for you to look at, and this is what I will be using when I come and watch your lesson plan implementations. All right, so back to our presentation here. Okay, so we are going to talk about the first 9 sections of this rubric, and I'm going to break them down. I'm going to give you some examples of ways that you can make a 3 or higher on the rubric. So the first one is standards and objectives. Now this, I personally think, is one of the easiest ones to make a 3 or 4 on. And the way you make an exemplary or significantly above expectation for standards and objective is that all learning objectives and state content standards are explicitly communicated to your students. The sub-objectives are aligned and logically sequenced to the lesson's major objective, right? Because you're going to have like this major objective for either the unit or the lesson, but then within that lesson, you have smaller things that you want your students to achieve. And your learning objectives are consistently connected to what students have previously learned, right? Because we want to be building on their previously earned knowledge or things that they might know from their life experiences. That also helps motivate students if they think about what they already know, and is also integrated in other disciplines. The expectations for student performance are clear, demanding, and high, and the state standards are displayed and referenced throughout the lesson. And there's evidence that the students demonstrate the mastery of that objective. That means that your assessment is going to have to show that your students have mastered that objective. Now, ladies and gentlemen, here's an easy way to do this. I always like to put a part of my board in the front, a section that has a Louisiana State Standard and then the lesson specific objective. And then right before we teach it, I say, hey guys, or girls, or ladies and gentlemen, this is what we're learning today. And I go over the very specific objective of what we're trying to do this day. And then I talk about how it integrates into this Louisiana State Standard. And then I might also have it written down either in the Google Classroom, or maybe it will be on an assignment as well. So my students hear it and they see it, and that would make a 3 or a 4 on that rubric, no problem. So here's an example of someone who could earn a 4 or a 5 in this area. The teacher says, today we will be creating a graph that illustrates how classmates responded to a questionnaire about sports using the pie, bar, or line format. I've put together a rubric to assist you in completing this assignment. When looking at the objective above, several sub-objectives could be identified. In reality, the needs of the students would determine what sub-objectives to include. For this example, there are a few sub-objectives that would probably be included in this lesson so that all students could be successful, like understand how to apply the pie, bar, and line graph. That would be from your prior learning, right? Because we're now applying it. So these students had to have learned when to use which graph. Be able to calculate the results of the survey into percentages. Again, that's probably from prior learning. And also be able to apply the rubric to the project. And so that's the process objective. Or if you're giving your students a rubric, you would hope they would use it to understand how they can earn the highest grade possible. Moving on, and this, I'm telling you all night right now, is something that I really look for in all of your lessons, and that is motivating students. And you're probably thinking, well, of course, Hollander, I motivate students. I always tell them, you can do it, and I'm their cheerleader. No, that's not what this standard is about. This indicator focuses on your ability to organize and present the content in a manner that motivates your students to learn. So it needs to be that you develop the types of learning experiences where your students can actually connect with the material. It makes this material relevant. And sometimes in science that can be tough, and sometimes it's ridiculously easy, right? So you really need to capitalize on your teacher knowledge of students to understand their lived experiences, because maybe that's the motivating factor. But also you need to capitalize on what their prior knowledge might be in the subject area. So the teacher consistently organizes the content so that it's personally meaningful and relevant to students. The teacher consistently develops learning experiences where inquiry, curiosity, and exploration are valued. This is huge, especially in science. And the teacher regularly reinforces and rewards effort. So even if a student's not understanding the topic, the student feels motivated to continue on and try to learn the topic, rather than just put their hoodie on and sit in the back of the classroom like this because they're completely checked out. Okay, here are some examples. So this is kind of more math related, but a teacher presents a lesson on measurement, and the students need to design a new school cafeteria because every single student eats in the cafeteria. So this is how it's motivating to the students. And so they have to apply the measurement skills taught. And then maybe the teacher invites an architect to speak to the students and explain how measurement is used in his own profession. So now they're giving a real life example and real life relevancy to what they're doing. In science, this is huge. Why don't we float around like we would if we were on another planet or in outer space, or like, why is it that some people, when they garden, are quite successful and others are not? There's lots of ways that you can make things very motivating to your students. But you need to know your students very well to make sure that you are using examples and analogies and concepts that are important to them. All right. The next one is presenting instructional content. Now, this is going to be very interesting because a lot of times you don't hear this. But for you to earn a 4 or 5, there needs to be a lot of visuals in your presentation. You also need to clearly communicate performance expectations in a concise and logically sequenced manner. So the presentation of content always includes visuals that establish the purpose of the lesson, preview organization of the lesson, and include internal summaries of the lesson. So that means you need to stop mid-lesson and say, okay, so let's go over what we just learned, or let's apply what we just learned. Okay, explain this to me in your own words. Define that term in your own words. That would be your way of having your students create these internal summaries. You would use examples, illustrations, analogies, and labels for new concepts and ideas, and that's so important in science. You would model by demonstrating the performance expectation. If I'm expecting you to use this new graphic organizer, I need to show you how to use it, right? And I'm going to do that in this lesson as well. Concise communication, logical sequencing and segmenting, right? You need to teach things in a logical manner. Only teaching essential information, no irrelevant, confusing, or non-essential information, no fluff. So if I'm going in there and I'm like, that was a great story, but how does that relate to the lesson? Then you are not doing a good job presenting instructional content. And please note, they talk about visuals a lot in this area of the rubric. So these are a couple examples. I always joke with my students that my students always know exactly how to earn an A in my class, right? Like almost all my assignments have rubrics. So knowing exactly what the expected outcome is. All right, guys, we're going to learn this concept, and then I'm going to expect you to be able to tell me sequentially all the steps of meiosis, and then apply it if I give you them all mixed up, right? You're explaining exactly what you expect the outcome to be. Also, you need to give the students defined steps so learning can achieve in that learning outcome. So you need to model the expectations for that assignment. So an example is a teacher explained to the students that the learning objective was for them to be able to identify physical characteristics of 2 characters from a novel and compare and contrast them. And then she goes ahead in the lesson and does that with 2 different characters, and she explains to them exactly her expectations of what she wants her students to be able to perform at the end of the lesson. Another part of the rubric is lesson structure and pacing. Now, especially for my newer teachers, this is tough, right? How many of us have done a lesson and we're like, oh, that went over way too long, or that was too short? Like, this happens all the time, but it's an easy fix because you learn very quickly like what your students can do quickly and where things are going to slow your students down. So this indicator blends time and form as it applies to instruction. It addresses the effective segmenting of the lesson, right? We need to give our students time to think about things and digest them, but also, like, are we presenting material in a logical manner? And are you giving your students enough time to learn this material and apply it? So the lesson needs to start promptly, right? Duh. And then the lesson structure is coherent with the beginning, middle, and end, as well as time for reflection. I think a lot of times we don't give our students enough time for reflection. And time for reflection could be as easy as, tell me how you're feeling about this material. Do you feel like we need to review it more? That could be your time for reflection. You have routines for distributing materials and they're seamless. This is huge, particularly when you're running a laboratory experiment or you're doing an in-class activity. And there's no instructional time lost during transition. So if you're having your students listen to you lecture and then they're breaking up into groups and then they're going to do a think, pair, share, and then they're going to share out and then we're going to go back to lecture, it needs to be very seamless where they've done this a few times and this is just part of the classroom management and students just understand the expectation going on here. The rubric indicator focuses on the following issues associated with instructional timing: prompt start, different learning rates, right? We're going to have students who are going to catch on very quickly to some concepts, and we're going to have some students that are going to need a little bit more time and they're going to need a little bit more practice. Seamless routines and smooth transition. Now, again, when you're a new teacher, you're working on that, right? You're working on trying to figure out the best way for you to give out materials, the best way for students to come in, get what they need, and get started with their bell ringer. And so sometimes that takes a little bit of time and practice before you really get to a 3, 4, or 5. So here's an example. A teacher begins a lesson on the causes of the Revolutionary War with an explanation of the learning objective and preview of the lesson. They then provide direct instruction by modeling how to complete a graphic organizer on the causes and effects of the war. The students are led to finish the organizer on their own as they read the text or other sources of information. The students who are below grade level in the reading continue to receive direct instruction from the teacher and assistance in completing the graphic organizer, whereas the students who are at or above grade level can complete the assignment independently and are provided additional activities to enhance their understanding of the cause. So that's a great way for you to understand who your students are, and the students that do need a little bit more help, you can guide them more closely. And then for the students that don't need as much guidance, they can move on independently and then as well start applying that knowledge in different ways while the other students are working. And then students complete an exit ticket before leaving class in which they reflect on which cause of the war they believe had the greatest impact. So that's your time for reflection. And that's a great little lesson, right? I think you guys can all think about ways that you can apply that to your own science lessons. Okay, this one should be easy. And I hope it is for you all. You also get evaluated on your activities and materials. Now, you all know that I love seeing you do and not just lecture, even though all I'm doing right now is lecturing at you right now, womp womp. But this indicator addresses the variety and appropriateness of activities and materials that a teacher chooses to implement during a lesson. I think you all know the whole point of the Next Generation Science Standards and the Louisiana Science Standards is that your students are going to do science. So activities and materials, y'all should be getting 3s and 4s and 5s on because your students should be doing the science. You should be using a variety of materials and activities, and your teachers can address a variety of learning styles and intelligences. So really what that means is that if you have students who might have a more difficult time with that concept, these activities and materials are going to address that. Now, we are in a situation where many of us are teaching online right now. You can still try different materials and activities, but those materials and activities are going to look a little bit different. Those might be Kahoots. Those might be using Jamboards. Those might be using at-home labs like kitchen sink labs instead of them coming into class and dissecting something. It might be them using an anatomy and physiology software. So you're still doing an activity, right? You're still doing science, but it just might not be with beakers and lab coats and scalpels and things like that. So something we really look at is the choosing of materials and activities should be those that clearly support the lesson objective. So make sure that the activity is not just like, I'm teaching my students about cold and hot, so we're going to make ice cream. Okay, that sounds like fun, but how is that going to meet the learning objective that you're trying to meet? So I need to see that the activity meets the objective. And that's where backwards design and other things that you've learned in lesson planning can help. Okay, so exemplary descriptors of activities and materials. They need to be challenging. They need to sustain a student's attention, elicit a variety of thinking, provide time for reflection, are relevant to student lives. Haven't we heard this already? Didn't we already hear about eliciting a variety of thinking in a different standard and also providing time for reflection? Didn't we just hear that in pacing? And are relevant to student lives? Isn't that motivating? So you can kind of see that we're starting to blend into other areas. You want to be able to provide your students with student-to-student interaction. Even if they're learning online, you can still do think, pair, share, and small group work over Zoom or Google Classroom. You want to induce student curiosity, right? We don't want to just give the answer away. We want them to figure it out. It provides students with choices. You can incorporate multimedia technology. You can incorporate resources beyond the school curriculum text. So maybe they need to get into the World Wide Web and start Googling away and finding examples of where the scientific concept is being applied today. In addition, sometimes activities are game-like or involve simulations. I'm a big fan of FRET, which I'm going to introduce to you later in the semester, but those are physical science simulations where your students can actually mess with the variables and see what happens. So when we're looking at activities and material, first we need to look at like the content related descriptors. Whatever activity or materials you choose have got to support the lesson objectives. They also need to be student centered, right? Do they sustain your students' attention? Do they provide opportunities for student-to-student interaction? Do they induce curiosity? And then, of course, there are the material descriptors. What exactly are you using? Are you using pipe cleaners? Are you using computer technology? You know, these are all different things that we would need to see. So something I always get is, how do I increase student participation? And I'm sorry, my little square doesn't do me any good right now. So I get questions a lot about how to increase student participation. So when beginning to develop these skills, teachers may ask the questions below as they observe a lesson or after they teach the lesson themselves. Were your students' attention maintained during the lesson, right? And when did you start to lose them? Because we all do. God knows I'm probably losing you right now at minute 27 of this lecture, and we would need to take a break and all stand up. How will I allow for meaningful student-to-student interaction, right? You don't want them to just like look at each other. You want them to peer review each other's answers, to really think about and come up with something together. How will I deliberately set the conditions for students to demonstrate curiosity? Hint, don't give the answer away in a YouTube video at the beginning of class. Like, truly give them a problem to solve. And then with choices, you have to think about how you'll provide students with significant choices related to the content. That might be how they're assessed. It might be the activity they do. It might be the variables that they're going to choose in the experiment. And then how will my students create and self-monitor their own learning? And that's a tough one. That's where you really need to start thinking about the reflection piece to your lessons. So here's a great thing. It's easy in science. You have them model something. You have them observe something. You do a science investigation. They predict an outcome before and after observing you doing something. A great place for you to have them self-monitor and reflect are in laboratory reports and science notebooks. I'm a huge proponent of science notebooks, and we're going to start talking about like the specifics of science notebooks in a few weeks and how you can use them. But it's a great way for your students to really monitor their growth over time. And then even better, during those parent-teacher workshops and meetings, you can use their lab notebooks and their science notebooks as a way to show the students' parents the growth of that student over time in your class. All right, y'all, we're coming to the end, I promise. The next one is questioning. Questioning is an art form. It reveals a great deal about a teacher's effectiveness, and the rubric descriptors provide a basic framework for the types of questions to ask within a lesson and how teachers should lead students in responding to the questions. Now, what I don't want to see is rote memorization, right? I don't need your students to give me the textbook definition of photosynthesis. I want to hear your students describing photosynthesis in their own words and then applying it and then problem solving with their knowledge of photosynthesis. So your questions need to be varied and high quality, providing a mix of balance of question types. So, you should be asking questions to assess your students' knowledge and comprehension, but also can they apply this knowledge? Can they analyze data with this knowledge? Can they create and evaluate? Doesn't this sound like Bloom's taxonomy? Because it is. So questions are consistently purposeful and coherent. And don't answer your own questions, okay? Okay, right? That's the worst when you hear a student, they're like, right? Right, moving on, because we all fall into that trap. High frequency questioning, we need to see a variety of folks. Questions regularly require active responses, not just from one student, but maybe you need to do some whole class, individual, small group. Here's something we also want to observe. Wait time is consistently provided. Give your students time to think about the answer. I'm terrible at this. The teacher calls on volunteers and non-volunteers and balances the students based on ability and gender. The worst is when I see you calling on the same 3 students who sit in the same spots in your classroom. Don't do it. And also, you want your students to generate questions that lead to further inquiry and self-directed learning. And maybe that's a great exit ticket, is for them to come up with more questions. So, when you're doing procedural questioning, please consider a couple of things. You need to ask a lot of questions during your lessons. You need to give them wait time. And you need to call on volunteers and non-volunteers. And I show you the popsicles because we are all familiar with the popsicles, where you write your name, you write all your students' names down on a popsicle in a cup, and it's like first period, second period, third period. And you pull the popsicle out and you say, hey, Chastity, what do you think of this? Or what do you think the outcome would be if we change this variable in the experiment? Another great way to do it that's science-y is if you're teaching chemistry, all your students, if they're sitting at a desk, they each have an element on their desk, and maybe you have a deck of cards with all the different elements. You just randomly pick an element, and you're like, who has iron? And you're like, okay, I want you to come to the board, and we're going to work out this calculation for molarity together as a class, but I want you to come up and get it started, right? So that's you asking a question, but also eliciting whole class feedback. Okay. There are 4 descriptors listed for questioning, and you can use a variety of questions to support student learning. One is the teacher questions are varied and high quality, right? You do want to know that your students actually understand the concept and know how to use the scientific lingo, but you also want to know that they can analyze data and understand what's happening and how that supports or negates a concept you're teaching. And eventually you'd like to get up to that high level of Bloom's, that creation and evaluation. Your questions are consistently purposeful and coherent. The worst is when we ask a question and your students don't understand what you're asking. And your questions are consistently sequenced with attention to the instructional goals. And finally, you want your students to be able to generate questions that lead to further inquiry or self-directed learning. So, you would like to turn these students on to science so much that they come up with their own questions. So here's a great example, and I like to do this with my elementary teachers, but also high school teachers. You guys can do this too. I think we all know about the KWL or the KLW chart. Okay, in science, we have the clues chart. The K is for what we think we know about this phenomenon. So you're teaching science, you present a phenomenon, and then you ask your students, what do you think you know about this? Right? And then you have the kids that think they know it all, and they're going to tell you. And then you have the kids that are like, I have no idea just what happened. Like, how do they stick a skewer through that balloon and not pop it? Right? Then you're going to ask them what they think we are learning. This hopefully they would know because you have already gone over the standards and objectives for this lesson. Then you will have them start collecting evidence, maybe from our data or from this lecture. Then you're going to ask them what they're still wondering. Oh, are we eliciting a question there? And then we're going to have them practice talking about that scientific concept and the vocabulary that they're learning. And the best part about this is they're not just writing rote definitions from the textbook about what is gravity, what is an element. No, they're putting it in their own words, which means they actually are learning it. And they'll know it when they get to that LEAP exam because they're going to understand the terminology and the concept, both as written in the textbook as well as in their own words. The next is academic feedback. Y'all, we always say, great job, yes, good, that was great. That's not what we're talking about here, okay? We are not talking about that type of academic feedback. We are talking about you giving focused, frequent, and high quality feedback. How many of us have turned in an assignment and all you get back is a great job? And you're like, that's good, but like, what's great about it, right? Like, I just wrote you a 5-page term paper on educational policy in Louisiana, and you said, great job. So what, right? I'm all about giving a lot of feedback. Feedback needs to frequently be given during guided practice and homework review, right? Okay, so if you answered it this way, let's talk about why that's not correct and how you can make that correct. How many people answered it this way? Okay, what were you thinking, right? You're getting to the nugget of like the why in the feedback. You walk around, you circulate, you look at student work, and maybe you point some things out. Hey, don't forget to convert your moles. Oh, I noticed that you answered this question this way. Maybe we should think about it a little bit differently. Have you thought about it from the perspective of the antelope versus the buffalo? Yeah, I'm thinking about IHUB right now. You also need to consider what type of feedback you're giving and how you need to adjust your instruction. If all your students are missing certain questions, then no doubt we are not teaching that concept very well. And then you're giving high quality feedback. Your students are giving each other high quality feedback as well. And that's going to take some time and some practice. So you always need to make sure your feedback relates to the lesson objective or sub-objective, right? You want to make sure that your feedback is to help them learn the objectives of that lesson. It needs to cause your students to think. So even if they get the answer right, maybe you challenge them with a challenge question. Your feedback needs to be very specific, not just like, yeah, maybe we think about this a little bit differently. No, you need to explain why they need to think about it differently. And your feedback needs to be timely. The worst is when you think you understand a concept and then you get to the exam and you don't know it at all and you've bombed it and you had no idea because you never received any feedback or assessment on that concept. And then it also needs to meet the needs of your students in your classroom, right? Some of your students might do better with written feedback, others with oral feedback. Some need to just one-on-one talk it out with you. So here's an example. Jonah, that is a terrific answer, and this is why. I like your point, but can we think of different ways to strengthen it using the new science terms we learned this week? You are going in the right direction, but what about thinking about it like this and then giving a specific way to think about it? Ways for your students to peer review each other is to review each other's writing, to do think pair shares and small group work. Something I really love doing is having individual student conferences, particularly after exams, if a student's done really well or not so well, where you provide oral feedback on major assignments. So maybe you sit down with each student and you're like, hey, I saw you really improved on this test, or hey, I saw you bomb this test. What's going on? Are there things going on in your life? Let's talk about the reasons why you got these questions wrong and how we can prevent that from happening in the future, and like really breaking down those questions and helping those students understand them so that they can do better the next time. And then of course, you can give great academic feedback if you use rubrics for assignments so students explicitly understand exactly what's expected of them. And finally, grouping of students. On your NIET rubric, for you to do well, you have to do some sort of grouping of students. And I understand that if you're teaching virtually this semester, that might be difficult, but students can still be paired together and you can still do small group work using Google Meet, Office Teams, or Zoom. So the instructional grouping arrangements, either whole class, small groups, pairs, or individuals, they can be heterogeneous or homogeneous, consistently maximize the student's understanding and learning efficiency. Here's the deal. There needs to be a rhyme and a reason for why you grouped your students the way you did, or you paired your students up the way you did. Let me give you a Hollander secret. On the first day of class at Nicholas State, I let you all pick your partners for an activity. And I watch and I observe you very closely, and I start to figure out who's partnering with who. And always the higher achievers find the other higher achievers, and the lower achievers always find the lower achievers, and the sorority sisters and the fraternity brothers always find each other, and everyone who's known each other since high school finds each other. And after that day, you will never be paired up or grouped with those people ever again. Because I need to vary your groups, and I need to make sure that they're heterogeneous, and I need to make sure that there's higher and lower achiever individuals in those groups, and I need to make sure that there are diverse groups for us to learn from, because in life, you don't get to choose your groups, right? You don't always get to pick who you work with, and the same goes for in school. So I really need to see instructional group composition that's varied, if that's through race, gender, ability, and age, socioeconomics, to best accomplish the goals of the lesson. Sometimes you need all your lower achievers in the same group because they're going to be the ones that you are going to guide them through everything, and your higher achievers can go do something else. It just depends on the lesson, right? Sometimes you want lower and higher achievers in the same group so they can help each other out. And instructional groups facilitate opportunities for students to set goals, reflect on, and evaluate their learning. And rarely do we see that. Also, give every group member a specific role. Please create meaningful roles based on the learning objective. If you're doing science, have someone be the data recorder, the materials manager. Maybe you have a director. That's also known as the direction reader, because sometimes my students forget to read the directions. You have a facilitator. You have a cleanup crew. There's lots of different roles you can give each group member. What's important, though, is if each member has a role, then they are committed to getting that assignment, that lab exercise, that activity done, and you have equal buy-in and your students are motivated. So please give everybody a role. And you need to be able to explain to us your rationale for grouping students. Like, why did you put them together the way they did? And sometimes there might not really be a reason. It might just be that you wanted to mix everybody up and see how they do to get to know your students better, which is what we like to do a lot early on in the semester. But you can think about it from demographic balance, interest, ability to focus, ability to communicate, by language acquisition levels. You know, if you've got English as second language learners, you know, there's all sorts of different ways that you might need to group your students. Okay. Finally, I think, is teacher content knowledge. This indicator addresses a teacher's knowledge of content. You need to know your stuff. That's what this is about. You need to be able to accurately explain the content, but you also need to be able to use different instructional strategies to enhance your students' content knowledge, which means that you need to know your stuff. And if you don't know it very well, you're not going to be able to teach it. You can always fake it till you make it, but you really can't. Your students are smart. And so you really need to think about it. So for example, you need to group your students are studying the circulatory and respiratory systems. And during their study of how the two systems function to support each other, they also study diseases of the two systems. Now, you're obviously going to need to understand both systems to understand how diseases affect each system. All right, and then teacher knowledge of students. I think y'all are great at this, though, and that is, how well do you know your students and how well they learn? And also, if you notice in red, you practice regularly how to incorporate your students' interests and cultural heritage. If you took my EDUC 441 class, that's all we focus on, is how to get to know your students and make those deep connections so that you can motivate your students, so that you know how to pace your lesson, so that you pick the appropriate activities and materials for your students. If you have strong teacher knowledge of your students, then you will do very well in other areas on this rubric, such as motivation. So who might need the lesson more scaffold? Who excels at writing versus explaining things orally? Who is English as a second language learner? Please use your students' names and pronouns properly. And is the lesson appropriate for this class? Does it need to be modified for fourth period versus fifth period? This is a great instructional adaptation for an inclusive classroom blog. I highly recommend it. It talks about really easy steps and pointers for any teacher to pick up. So we are done. It has been a very long 45 minutes, and I'm so sorry that this lecture is so long. I hope you broke it up into a couple chunks. But this week's assignment is, based on the 9 presented parts of the NIET rubric, I want you to take a lesson plan you have written, taught, or both. So if you're using scripted curriculum, you obviously did not write that lesson, but you've taught it. And I want you to identify 3 areas on the rubric you feel you would excel in and 3 areas that could use some improvement. Then explain in the evidence collection how you meet these areas well or how you might improve these specific areas. And I want examples. So if you're doing something well, I want you to tell me in bullet points specific evidence of how you're doing it well. The students are going to do X, Y, and Z, or this is how I'm going to present the standards and objectives. Whatever it is, it needs to be very specific. Like if I were in your classroom, I would understand. And for areas of improvement, again, give me concrete examples of how you would improve this area on the rubric. This is a 25-point assignment. I give you a graphic organizer on Moodle on how to do this. And if you have any questions, please email me. Thank you all for sitting through a 45-minute lecture with me online. I appreciate you all, and I cannot wait to see you soon. Take care.